Our next presentation is from ArielTimkovich. Ariel is a third-year PhD student in microbiology within the Department of Microbiology, Immunology, and Pathology. And Ariel knew she wanted to study arthritis when she learned that it is a leading cause of disability affecting 23% of all adults in the US. With her degree, she hopes to perform preclinical testing on pharmaceutical drugs and therapeutics. And Ariel's title today is A Receptor Gone Bad: The Tale of Uncontrolled Inflammation and Joint Degeneration.
Our bodies contain millions of circulating cells whose role is to patrol the body and search for outside invaders. These invaders can come in the form of any microorganism, such as bacteria, viruses, or fungi. Our bodies need to quickly detect the invading pathogen and rapidly recruit other immune cells to the location of infection to launch a swift and precise removal of the invader. Our immune systems are able to destroy invaders by directly removing them and also by releasing toxic substances into our body that will kill them. One such way our cells detect invaders is through receptors on their own cell surface. These receptors are specialized to detect a unique portion of a specific pathogen so that our bodies can mount an appropriate immune response to the specific pathogen. For example, we have a receptor that specifically detects the outside of bacteria. When bacteria are present in our bodies where they shouldn't be, these cells, through their receptor, detect that the bacteria are there and notify the rest of the immune system that they should come and fight off the bacteria. Now, this system works great, but it can get confused. This specific bacteria detecting receptor seems to be a bit promiscuous. Say you're skiing and you fall and hurt your knee by tearing your meniscus or rupturing your ACL. Even though there are not any bacteria in your knee, the debris in your knee from the injury, such as damaged cells or blood, is able to somehow activate this bacteria-specific receptor. The activation of the receptor recruits immune cells to the knee, and they launch a full-blown attack to clear the infection, except there is no infection, and the debris in your knee doesn't go away. This unrelenting attack ultimately damages cells within the knee, which produces more debris that binds our bacteria receptor. This self-perpetuating cycle leads us to end up with chronic inflammation in the knee and joint degeneration known as arthritis. Now, I know this sounds bad. I just told you that if I injure my knee, debris from the injury will inappropriately activate my bacteria receptor and will cause more debris, which will eventually lead to arthritis in my knee. Don't worry, there's hope. My research has demonstrated that mice that don't have this receptor get significantly decreased amounts of arthritis following knee injury. We are also able to use a therapeutic to block this promiscuous bacteria receptor after knee injury and prevent the chronic inflammation cycle and subsequent arthritis progression. Best of all, as this bacteria receptor is involved with pain perception, use of this drug also resulted in the animals moving and feeling better. This means we can develop a therapeutic for humans that will help to prevent arthritis from forming in the joint following injury to the joint.